All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answer. So for the factoring, you're going to multiply the 4 by the 9 to remove it, and you'll have x squared plus 12x plus 36. Then you're going to factor it, so it'll be x plus 6 times x plus 6. You're going to replace the 4 that you removed at the beginning, and then you're going to reduce them. So that's going to become 2x plus 3 and 2x plus 3, which again you can write as 2x plus 3 squared. So this could be your answer, or this one. Either one is fine with me. Okay. For the math knowledge question, we're going to set up a system of equations. We have red, blue, and green, a total of 76 of them. She finds that she has 4 more red than green. So there are more reds, so you have to add 4 to the greens because she has more red than green. And then she has 6 more red than blue, or 6 more green than blue. So she has more green, so you have to add 6 to the blue. So I am going to make this, instead of putting plus 4 here, I'm going to make it minus 4 for the red to make it match up with the green. And then, no, I'm not going to do that. I'm going to plug in my R into my equation here, and it'll be 4 plus G plus B plus G equals 76. So B plus 2G would equal 72. And then I know that G equals B plus 6. So I can plug B plus 6 in here and then distribute. And then you would have 3B equals 60. And so the number of blues is 20. So it said how many red discs does she have? We have blue is 20. So that means that our green is going to be 26. And then our red is 4 more than that, which would be 30. And these should add up to 76, which they do. So the red total is 30. So that's how you would solve that math knowledge question. Okay. Now we're going to look at lesson 22. We're going to deal with binomial expansion and then recognizing the equations of conic sections. So the binomial expansion you should have done last year in pre-calculus. You may not have used this formula that we're going to go over. You may have used Pascal's triangle, which is good, but if your exponent is a large number, like 12 or 15 or a big number, anything more than about 7 or 8, you don't want to use Pascal's triangle just because you have to go out so far on it. And then equations of conic sections, you should have dealt with conics last year for sure in pre-calculus. So hopefully most of this is review. Hopefully, we'll see. So your binomial theorem gives you a pattern that you can use to find the term in your expansions to some positive integer power. So if n is a positive integer power, then this formula is going to hold true. It may look a little bit confusing, but it's really not. It's just a pattern that you use over and over and over again. So on the first one, if you look here, n minus 0 is just n factorial, and then 0 factorial is 1. So we really just have n factorial over n factorial, which cancels out. But they wrote it out so that we can see the pattern. And then our 0, n minus 0 is here, and 0 is here. S to the 0 is just a 1. It disappears, basically. And so you're really left with this first term just being f to the n. And then for your next one, you plug in 1 instead of a 0 everywhere. And then you plug in 2, etc., until you get to where your n is now your s exponent. So if this is a 10, you would get out to 10 here, and then you would be done. Okay, so we're going to use that formula in an example to help go over it a little bit more. So this is our formula that we're going to use. we want to write the expansion of x plus delta x to the 7th. And you may be thinking, why do I have to know how to do it? It says the expansion is crucial in determining the derivative of x plus 7, x to the 7th. So we're working towards being able to find derivatives of higher powers. So what we're going to do first, our f is going to be our x, and our s is going to be our delta x. So again, this first term is just going to be your f to your exponent. So x to the 7th. Plus, our n is a 7, because that's what our exponent is. So we're going to do 7 factorial over 7 minus 1 is 6 factorial, and then 1 factorial. These two numbers should always add up to this number up here. And then 7 minus 1 is 6, and then delta x to the first. So I'm going to write it, but you don't need it necessarily. These exponents should always be the same as these numbers here. So this is a 6, and this is your 1. Plus 7 factorial over 7 minus 2 is 5 factorial and 2 factorial. Again, they add up to 7. And then we're going to have x to the 5th and delta x squared. So the next one, we don't have it written up here, but it's going to be 7 factorial. And instead of it being a 5, it's going to be a 4, which makes the other one a 3. And then you're going to have x to the 4th and delta x to the 3rd. So you'll see in the pattern maybe a little bit, hopefully. The next one, you're going to do 7 factorial over, so we started 6, 5, 4, we're going to have 3 factorial, and then 4 factorial, because again, they have to add up to 7. So x to the 3rd and delta x to the 4th. The next one is going to be 7 factorial over 2 factorial, 5 factorial. X squared and delta x to the 5th. The next one is going to be 7 factorial over 1 factorial, 6 factorial, x to the 1st, and delta x to the 6th. And the last one is just going to be delta x to the 7th. Okay. So now we're going to simplify these. And so you need to use a calculator if you want, or you can do it in your head, either one. The first term is just going to be x to the 7th. Seven factorial over 6 factorial is just 7. So 7x to the 6th and delta x. If you want to write it first, you can. You don't have to. And then 7 factorial over 5 factorial times 2 factorial is 21. So you should have 21 x to the 5th delta x squared. So I'm going to show you how to plug that into your calculator, and then I'm not going to do it for the other ones. So you're going to have 7 factorial. So your factorial is going to come from math, and you're going to go over to probability. And then it's number 4. So you hit 4, and it does it. And then you're going to divide it by, open parentheses, 5 factorial, 2 factorial. And then close parentheses, and you hit enter, and there it gives you the 21. You have to put parentheses around your whole denominator, not around 5 factorial and 2 factorial. So that's what you want it to look like. 7 factorial divided by, open parentheses, what's in the denominator, and then close parentheses. Okay? So again, I'm not going to go over that for each one. Okay, so the next one is going to be plus 35 x to the 4th delta x to the 3rd. and then you're going to have plus, again, 35, because it's still a 3 and a 4, x to the third delta x to the fourth, plus 21 x squared delta x to the fifth, plus 7x to the first delta x to the sixth, plus delta x to the seventh. And so this would be your answer here. Okay, so that's how you can use a formula. Typically, they're not going to ask you to write all of the terms. They're just going to ask you to find one of them. So if this had said to find the third term, our third term is, this is the first one, this is the second, this is the third one. Okay, and in the formula, this is the third term. This one right here. That is your third term. And if you look, the number that we're subtracting from n is not a 3, it is a 2. And the reason, your first term you subtract 0, then your second term you subtract 1, and your third term you subtract 2. So that's where it gets a little bit tricky when it asks for a certain term. So on this one it says find the 8th term. So we're not going to subtract 8. What are we going to be subtracting to find this one? It's always 1 less than the number term. So we're going to be subtracting 7 from our n. So I'll bring our formula down just so you can kind of see it. But you're going to do n factorial, so that's 12 factorial, over, and then instead of any of these, it's going to be n, which is 12, and our number we're going to subtract is 7. And then we're going to do 7 factorial, and then f to the 12 minus 7, and s to the 7. So that's what you would do there. So 12 factorial over, you should have 5 factorial and 7 factorial, and then f to the 5th and s to the 7th. Okay, so now you use your calculator to figure out your coefficient. And if you do your parentheses correctly, you should get 792, f to the 5th, s to the 7th. Okay, so if you didn't get that, y'all can pause the video real quick. Someone help their neighbor figure out what they did wrong on their calculator so that they can get 792. Okay, we're going to look at the next example. We want to find the 10th term of the expansion 2x cubed minus y. So this one's a little bit different in that it's not just an x, delta x, or an f and an s. It's 2x cubed and a negative y. So first thing we need to do is figure out what are we going to subtract. We're going to be subtracting 9 because it's always 1 less than this. So our n is 15 because that's our exponent. And then we're going to do 15 minus 9 factorial, and then 9 factorial. And then our first term is 2x cubed. So all of that is raised to the 15 minus 9. And then our second term is negative y, and all of that is raised to the 9. You have to include the negative whenever you plug it into your formula. Okay, so from here, we're going to simplify 15 factorial. 15 minus 9 is 6 factorial, 9 factorial. So we have 2x cubed to the 6th and negative y to the 9th. And so now we need to simplify it. So plug into your calculator and figure out what your coefficient is going to be. So you should get 5,005. Now we have to do 2 to the 6th, which is 64. And we have to do x cubed to the 6th. So 3 times 6 is 18. And then we have to do, this is a negative 1 to the 9th, a negative 2, an odd power, is going to be negative, and then y to the ninth is going to be y to the ninth. If this had been negative y to the eighth, that would be a positive y to the eighth, because a negative to an even power would become positive. Okay, from there, you're going to do 5,005 times 64. And you're going to have in times and negatives, so negative 320, 320, 320,320. And then we have x to the 18th and y to the 9th. And so that would be your answer. Okay, we're going to look at the recognizing equations for your conics. So we want to tell whether it's an ellipse, hyperbola, circle, or a parabola. So hopefully you dealt with this in pre-cal last year. We basically need to look at our x squareds and our y squares. So on the first one, we have 4x squared and a 36x squared, y squared. They're both positive, but they are different numbers. So it's not going to be a hyperbola or a parabola, because we have an x squared and a y squared that are both positive. But since they are different numbers, it's not a circle, it's an ellipse. Okay, looking at the next one, we have a 9x squared and a negative 4y squared. So since we have an x squared and a y squared, it's not a parabola. Since one of them is negative, it is a hyperbola. Okay, looking at the next one, we only have a negative y squared. So since we only have one squared, what is that going to make it? Hopefully you're saying a parabola. Only one of them is squared, so it's a parabola. And we could make it positive by moving it over to the other side. We're not so concerned about whether it's a negative or a positive, though. For the next one, we have an x squared and we have a y squared. They're both positive, and the coefficients are the same number. They're both a 1. If they had both been a 4, then it would still be a circle. As long as they're both the same number and they're both positive or both negative, then it's a circle. Okay? And looking at the last one, we have an x squared and a 36y squared. So those are both positive, and they're different numbers. So what is that going to be? An ellipse. Okay, so that would be your answer for this. On your test for these, sometimes it'll ask you to identify what it is and graph it. So when it says graph it, it means not on the graphing calculator. It means graph it using an XY chart, a XY graph. So you need to refresh on how to graph an ellipse and a hyperbola and a parabola and a circle. You should have gone over those in pre-cal last year. So make sure that as you practice graphing those on your homework, if it says to graph it and it doesn't show you a picture from a graphing calculator, like it actually just does a graph of it, that you make sure you know how to graph those. I'm going to go quickly over a hyperbola. I'm just going to make up some numbers. So that would be it in standard form. You'd have to complete the square to get it there. And then your center is going to be at 4, 3. So you would go over 4 and up 3. And then you would go left and right 3 and up and down 2, because that's the square root of 4 and 9. And then you're going to draw a box. And then you do asymptotes that go through your diagonal vertices. And this is a very rough sketch. And then, if it's a hyperbola, I'm sorry, that should be a minus, not a plus. So x squared comes first, so it's going to be on the x side, left and right. And so it's going to look like that. If it had been y squared minus x squared, so if it were y squared minus x squared, it would be going this direction. So that's a basic review of a hyperbola. I'm not going to spend any more time going over the other ones because you should have learned them all last year. So if you need to look back at some lessons from last year from pre-calc, then you'll need to go over those. Okay, so hopefully you'll be able to do all of your homework 1 through 25 tonight, and then we're going to go over any questions you have tomorrow.